Look up at the night sky. That faint, shimmering band of light is the Milky Way, our home in the cosmos. For millennia, people saw it as a celestial river, a path for gods, or a river of milk. Today, we know it's a galaxy, a vast, swirling collection of stars, gas, and dust. We are inside it. Every star you see with the naked eye is part of this immense structure. The Milky Way is one of hundreds of billions of galaxies in the universe, but it's special to us because it's ours. It's a place of creation and destruction where stars are born in clouds of gas and die in spectacular explosions. Our galaxy spins, carrying us on a journey through space at incredible speeds. Understanding the Milky Way is a journey of self-discovery, about our origins and our place in the universe. The scale is staggering. If our solar system were the size of a coffee cup, the Milky Way would stretch across North America. Light takes about 100,000 years to cross it. The light from distant stars began its journey when early humans first walked the Earth. We are a tiny part of this immense structure, orbiting an average star in one of its spiral arms. So let's embark on a journey through our galactic home, from the familiar night sky to the mysterious heart of the galaxy. We'll explore its structure, meet its diverse inhabitants, and ponder its future. This is the story of the Milky Way, our galaxy. From Earth, we don't see the Milky Way's spiral shape. We're inside it, like someone lost in a city. That Milky Band is our view into the densest part of the galaxy's disk, a blend of countless distant stars. The ancient Greeks called it the Milky Circle, and the name stuck. The Milky Way's appearance changes with the seasons. In summer, we see the bright, crowded center. In winter, we look toward the fainter outer edge. This shifting view reminds us that we're in motion, orbiting the sun and tilting our perspective on the galaxy. Sadly, light pollution hides this view from most people today, disconnecting us from our cosmic home. Our galaxy is part of the local group, a small collection of galaxies including Andromeda and dozens of dwarfs. The Milky Way and Andromeda are the giants, bound by gravity and destined to merge in about 4.5 billion years. This won't be a violent crash, but a slow, graceful cosmic dance. Over time, the two galaxies will blend into a new, larger galaxy. Even as we look up, we're witnessing a moment in a much larger story. The Milky Way's future is written in the stars, and in the space between them. Our view from Earth is just one chapter in that ongoing cosmic tale. If we could step outside the Milky Way, we'd see a majestic, rotating disk with bright spiral arms and a glowing central hub. The main structure is the galactic disk, 100,000 light-years across, but only 1,000 light-years thick. Most of the galaxy's young, bright stars, gas, and dust are here, including our Sun, about 2/3 from the center. At the heart is the galactic bulge, a dense, spherical swarm of older stars. Surrounding everything is the galactic halo, a vast, ghostly sphere filled with ancient stars and globular clusters, fossils from the galaxy's youth. The spiral arms are density waves, not solid structures, like cosmic traffic jams that trigger bursts of star formation. That's why they shine with hot, young blue stars. Our solar system sits in a smaller arm called the Orion Spur between the larger Sagittarius and Perseus arms. The Milky Way structure is a dynamic, layered city of stars, each part telling a different chapter of its history. Understanding this anatomy helps us see where we fit in the grand design. The Milky Way is a stellar factory with spiral arms full of cold molecular clouds, stellar nurseries where stars are born. Gravity pulls gas and dust into dense cores, igniting nuclear fusion and creating new stars. This process is ongoing, visible in places like the Orion Nebula. Stars come in all sizes and colors, massive blue giants that live fast and die young, stable yellow stars like our Sun, and countless long-lived red dwarfs. The life of a star is a battle between gravity and fusion. When fusion ends, gravity wins. Sun-like stars shed their outer layers as planetary nebulae, leaving white dwarfs behind. Massive stars explode as supernovae, forging and scattering heavy elements like iron and oxygen across the galaxy. These elements are the building blocks of planets and life. We are literally made of stardust, born from the ashes of ancient stars. The cycle of star birth and death connects us to the galaxy's ongoing story. Every atom in our bodies has a cosmic origin. The Milky Way's lifeblood is the story of creation, destruction, and renewal. For most of history, we only knew the planets in our solar system. That changed in the 1990s with the discovery of exoplanets, worlds orbiting other stars. Now we know planets are common. There are likely hundreds of billions in the Milky Way. These exoplanets are incredibly diverse. Hot Jupiters, super-Earths, planets orbiting two stars, and even worlds around dead stars. The galaxy is a planetary zoo, stranger than we ever imagined. One of astronomy's great quests is finding Earth-like planets in the habitable zone, where liquid water could exist. Dozens of potentially habitable worlds have already been found, bringing us closer to answering, are we alone? Our solar system is just one example, with rocky inner planets and giant outer ones, a stable system that allowed life to flourish. By studying other planetary systems, we learn what's common, what's rare, and how worlds like ours form. Comparative planetology helps us understand our own home's place in the galaxy. Each new discovery adds a piece to the puzzle of our cosmic neighborhood. The search for other worlds is the search for our own origins. At the Milky Way's center lurks Sagittarius A, a supermassive black hole with the mass of 4 million suns. Its presence was revealed by the frantic orbits of nearby stars, and in 2022, we saw its shadow for the first time with the Event Horizon telescope. This black hole shapes the galaxy, influencing star formation and galactic evolution. As matter spirals in, it heats up, shining brightly and sometimes launching powerful jets. The Milky Way also contains millions of smaller, stellar-mass black holes, the remnants of massive stars that died in supernovae. These dark objects are detected by their gravitational pull, or by the X-rays they emit when feeding on companion stars. Black holes are the galaxy's hidden engines and silent ghosts, shaping its fate from the shadows. They remind us that the most powerful forces in the universe can be invisible. Studying the Milky Way is like mapping a forest from within, with dust clouds blocking our view. To see through the dust, astronomers use radio and infrared telescopes, revealing hidden stars and the galaxy's structure. Radio waves map hydrogen gas, tracing the spiral arms. Infrared light peers into the galactic bulge and star-forming regions. Spectroscopy splits starlight into its colors, revealing temperature, composition, and motion. By analyzing millions of stars, we build a dynamic, 3D map of the galaxy. The Gaia Space Observatory is revolutionizing our understanding by precisely measuring over 1 billion stars. Computer simulations let us watch virtual galaxies form and evolve, testing our theories against reality. If the simulations match what we see, our understanding is on track. If not, new mysteries emerge. These tools turn the Milky Way into a cosmic laboratory. Every new technique brings us closer to unraveling the galaxy's secrets. The challenge of studying our home only fuels our curiosity. The more we learn, the more wondrous the Milky Way becomes. The 20th century brought a revolution. We learned the Milky Way is just one galaxy among billions. Edwin Hubble proved that distant nebulae were actually other galaxies, expanding our view of the universe. This discovery shattered old ideas and placed our galaxy in a vast cosmic context. Another breakthrough was the discovery of dark matter, an invisible substance making up most of the galaxy's mass. Vera Rubin found that stars on the galaxy's edge moved faster than expected, revealing the presence of this unseen matter. Dark matter forms a giant halo around the Milky Way, shaping its structure and evolution. More recently, we've uncovered evidence of galactic cannibalism. The Milky Way grew by merging with smaller galaxies. Stellar streams, trails of stars from devoured galaxies, arc across the sky, recording this violent history. The Gaia Observatory has been key in mapping these streams, revealing our galaxy's dynamic, ever-changing nature. Each discovery rewrites the story of the Milky Way and our place within it. Learning about the Milky Way is more than collecting facts. It's about understanding our place in space and time. We live on a fragile planet, orbiting an ordinary star in a quiet corner of a vast galaxy. This perspective is humbling and unites us as citizens of the cosmos. Our journey of discovery is powered by curiosity and ingenuity, telescopes, simulations, and the drive to explore. Every new finding, from exoplanets to black holes, is a triumph of human imagination. The exploration of the Milky Way is just beginning. Countless mysteries remain. What is dark matter? How common is life? What happens inside a black hole? Each answer leads to new questions. The universe is stranger than we can imagine, and that's what makes science thrilling. So next time you see a dark sky, look up and find that glowing band of light. That's your home. The combined light of billions of stars stretching across 100,000 light years. You are a citizen of the Milky Way, made of stardust, part of a grand cosmic story. The journey to understand it all is a noble, essential part of being human. Keep looking up.